Ever looked up at the night sky and just felt like completely overwhelmed?
In a good way. That's what we're diving into today. That feeling, where science meets the totally unknown.
And it's not just, stars twinkling way out there. It's stuff that could completely change how we live right here.
Yeah. And to help us wrap our heads around it all, we're using this wild book by physicist and entrepreneur Raymond Caldas.
Over 35 years, this guy's been digging into quantum physics, AI, even energy systems.
Yeah.
He connects the dots like no other.
Seriously. So first up, we got to talk quantum mechanics. Caldas calls it the most revolutionary theory of the 20th century. Makes you wonder what's real.
For sure.
Yep.
Like, for centuries, we thought physics was all neat and predictable. Then, boom, quantum mechanics shows up. Turns out the universe is way weirder and cooler than we thought. Like particles acting like waves, existing in multiple states. It's almost like, is this chair even real? Or are there infinite me's wondering the same thing across the multiverse?
And that's the heart of it. Wave-particle duality. The universe is basically messing with us. It's like, thought you knew the rules. Nope.
Yeah.
Imagine an electron, not a solid thing, but a blur of possibility, a wave spread out.
So, not in one place, but everywhere at once. Kinda?
Exactly. But get this, when we actually look at it, try to pinpoint it, it collapses, becomes a particle again. Like, observation makes the universe choose one reality out of like a million possibilities.
Okay, whoa. My brain's already hurting. But Caldas doesn't stop there. He goes into quantum superposition, which is even weirder.
Picture yourself at work, on a beach, and also on Mars all at the same time. That's what particles can do with superposition. Until someone's looking, they're in all those states at once. Blows your mind, but it could lead to some crazy breakthroughs.
And this is when things start to get really interesting, right? Like, how could this impact us in the real world?
Think about a computer doing a million things at once. Not
Sure.
one after the other, but all together instantly. That's the whole idea behind quantum computing. Medicine, materials, everything changes.
So we're talking new medicines designed specifically for your DNA, materials with properties we haven't even dreamed of, and all that happening way faster than we thought possible.
Exactly. It's like unlocking a whole new level of possibility, and that's just the tip of the iceberg.
It's kind of mind-blowing when you think about it, Like, these tiny little particles could hold the secrets to, well, everything.
It's true, though. The tiny stuff might just explain the really big stuff. Speaking of, we got to talk about the big guy in the room. Or should I say, the stuff we can't even see? Dark matter and dark energy.
Right. It's wild. Like, all those stars, galaxies, everything we can see, that's barely anything.
5%, if you can believe it. The rest. Yeah, Caldas calls it the biggest mystery in science right now. This invisible stuff, it's literally shaping the universe, like the whole destiny thing.
So not just empty space, right? There's something there, but we just can't see it.
It's got pull, though. Gravity. Galaxies shouldn't even exist the way they do, spinning so fast. But there's something holding them together. Dark matter, like the cosmic glue, I guess you could say.
Imagine trying to put a puzzle together, but most of the pieces are invisible. How can you even study something like that?
It's tricky, no doubt, but scientists have figured out ways. Like, instead of seeing it directly, you look for clues. How it bends light, for example. Like a cosmic magnifying glass. Gravitational lensing, it's called.
Okay, so dark matter is holding things together, but dark energy, that's like the opposite, right? That's what Caldas says, at least.
It's pushing everything apart, hard to get your head around, but imagine, like a balloon. But instead of slowing down as it gets bigger, it just keeps expanding faster and faster. That's dark energy.
Whoa, that's pretty intense. So the universe isn't collapsing in on itself, it's getting bigger, like forever.
That's the leading theory, yeah. Not what scientists used to think, but why? That's the million-dollar question. Maybe it's part of space itself, but honestly, no one really knows yet.
Sounds like we need some serious brain power to crack this one. Any hope of figuring all this dark stuff out anytime soon?
See, the universe keeps throwing curveballs,
Just when we think we're getting a handle on things, bam! It's time to talk about the big daddies of weirdness.
Black holes.
Black holes, yeah. Those things are like the ultimate cosmic mystery. Scientists, sci-fi nerds, everyone's fascinated by them.
I gotta admit, they kind of freak me out. I mean, these things are so dense, not even light can escape. That's some serious stuff.
Caldas says there are places where gravity basically goes wild. Imagine all the matter in, like a whole star, crushed down to a single point. Our understanding of the physics just kind of breaks down. So what would happen if, like, you fell into a black hole? Hypothetically, of course. Besides, being instantly spaghettified.
Well, first off, there's this thing called the event horizon. That's the point of no return. Cross that, you ain't coming back.
So it's a one-way ticket to where? What happens inside?
That's the million-dollar question. But here's the thing about black holes and time. Time gets all wibbly-wobbly the closer you get.
With the weapon.
Yeah, like imagine falling in and time slows down for you, but for everyone else, it keeps ticking along normally.
That's trippy. Like time travel, but only in one direction.
Exactly. And as you fall further in, time keeps stretching and stretching until, well, we don't really know for sure. Some serious brain melty stuff.
No kidding. So our current physics can't even explain what's going on inside a black hole.
Not really. That's why physicists are coming up with new theories all the time, like loop quantum gravity. That one's pretty wild. Basically, it says space-time itself is made of these tiny little loops, and those loops have a minimum size, so the singularity at the center of a black hole can't actually collapse to a point.
So even inside a black hole, there are still rules, just different ones.
Maybe. That's the beauty of it, right? The universe is full of surprises.
This whole deep dive has been full of surprises. We've gone from tiny particles to giant black holes. It's kind of overwhelming in a good way.
It really makes you appreciate how much we don't know, but also how much we're learning all the time.
That's what I'm taking away from all of this. Like, the universe is this giant, mysterious place, and we're just starting to scratch the surface. But hey, that's what makes it exciting, right? The not knowing, the always discovering.
Absolutely. Who knows what mind-blowing secrets are still out there waiting to be found? Maybe you, listening right now, will be the one to discover them. So keep looking up, keep asking questions, and never stop exploring the universe, both inside and outside your own mind.